Hello everyone. Today we are going to know about the fourth experiment of our DDCO Lab experiment, that is design a 4-bit full adder and subtractor and stimulate the using basic gates. We have to design 4-bit full adder and subtractor, and we have to write program for that, and so we have to stimulate the same using basic gates.
So let us now understand by this by taking an example. Let us consider A is equal to 3 and B is equal to 10, and we will shall write this in binary form. When we write this in binary form of A, it becomes 0, 0, 1, 1. When we write the binary form of B, it becomes 1, 0, 1, 0. Now we'll know that how to write this 2 in binary form. So to write in binary form, we will consider up to power of out up to power of 3. So that is 2 cube, 2 square, 2 to the power of 1 and 2 to the power of 0. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. So to get 3, we have to to use 2 here. So we will put 1 here and we have to put 1 here. So by adding up these two we will get 3 and remaining will become 0. So this is for A. So for getting 10 or for getting B, we have to add 2 cube, that is 8, and 2 to the power of 1, that is 2. Remaining becomes 0, so that becomes 10. So this is the method to write any numbers in binary forms. So let us add these two. When we add 1 plus 0, it becomes 1. When we add 1 and 1, the carry out will be 1 and sum will be 0. When we add 0 and 1, it becomes 1. So when we write this here, 2 cube becomes 1, 2 square becomes 1, and 2 power 1 becomes 0, and 2 power 0 becomes 1. So 2 cube 8 plus 4 is 12, 12 plus 1 is 13. So the sum becomes 13. Now we will understand about a 4-bit full adder. Here we consider A, B. This is A naught, B naught, A1, B1, A2, B2, A3, B3. First, we will consider A naught and B naught. Here A naught is 1 and B naught is 0. And first the carry in remains 0. When we add 0 plus 1, the sum 0 plus 1, the sum becomes 1 and carry out becomes 0. This carry out is carried to the next full adder, and here next in the second, so in this full adder the carry in becomes 0. We know that a1 is 1 and b1 is 1. When we add 1 and 1, the sum becomes 0 and carry out becomes 1. Where this carry out is passed to the next full adder, here the carry 1 becomes 1. Here we know that a2 b2, a2 b2 are 0 and 0. When we add 0 plus 0, 0, 0 plus 1 is 1 and carry out becomes 0. This carry out is passed to the next full adder, and that becomes next full adder carry in becomes 0. We know that here 0, 1 here. So this carry out is passed to the next full adder, and here in this full adder the carry in becomes 0. We know that a3 and b3, that is considered as a3 and b3, 0 and 1. When we add 0 and 1, it becomes 1. 1 plus 0 becomes 1 and carry out becomes 0. So we can note that then these are the inputs. So after solving a 4 bit full adder, here 1 1 0 1 1 1 0 1. This is same as that we have got from adding two in binary values. So now we will understand about 4-bit full subtractor. We will take two binary values. A will become 0 1 1 1, and B we will take it as 1 0 1 0. When we subtract these two binary values, we get 1 minus 0 is 1. 1 and 1 becomes difference becomes 0, and 1 0 difference becomes 1, and 0 1 difference becomes 1, and bar out will be bar out will be 1. So in this special case, the output, that is S3, S2, S1 and S0, will be this 4, and this one will be go to bar out. So let us see this by solving this 4-bit full subtractor. So as we know that these are A and B, and this will become A naught, B naught, A1, B1, A2, B2, A3 and B3. So first we will consider A naught and B naught. When we consider A naught becomes 1, B naught becomes 0. First the B1 remains 0. When we take the difference of 0 and 1, it becomes 1. 1, and when we take the difference of 1 and 0, it becomes 1, and the bar out will be 0. This bar out will be carried to the next full subtractor, and here bar in becomes 0. We know that a1 b1 value, a1 is 1 and b1 is 1. 1 and 1 difference is 0, and 0 and b in difference will be 0, and b out becomes 1, and this bar out is carried to the next full subtractor. Here b in becomes 0, and we know that a2 b2 value, b2 becomes 0, a2 becomes 1. So now b2 becomes 0, a2 becomes 0. When we get a difference from 0 and 1, it becomes 1. 1 and 0 difference will be become 0, and bar out becomes 0, and this bar out is carried to the will be carried to the next full subtractor, and we are borrow in becomes 0. We know that b3 a3 values, b3 is 1 and a3 is 0. When we subtract 1 and 0, we will get 1. 1 and 0 again becomes 1, and here it will takes borrow in, and this borrow out becomes 1. So this is the output we have got after solving 4 bits full subtractor. As we can see that 1101, so before we also got the same 1101, and the borrow out will be remains 1, and here also borrow out will be 1.
So this is the program for 4-bit full adder and subtractor. You can take screenshot of this. Yeah, we have solved this example. We have taken two values, that is A0111 and B1010.